Okay, so hello and welcome to my video. My name is Edwin. I am an embedded systems maker. Currently, I'm a student, final year, and I'm going to start, or rather, this is the first video of a series for a project I am building. I'm starting to build. So I'm going to introduce the project and then tell you the motivation behind it, and just outline a few systems we are going to design and build together, and maybe the goals and the expected results of the project. And yeah, so I'm going to build an homemade nanosat. Homemade nanosat. I drew up a few designs few weeks ago. So I know some guys doing this already, but I just want to give myself a challenge and build one on my own from scratch using a different stack, a different approach for this satellite. So these sketches show just what I was thinking at that moment. Obviously, it's going to be a cube shape or a 1U satellite. The sketch in the middle shows a closed box design with the solar panels on the side here. The top here shows the PCB stack up. So these are just PCBs that I have laid out together. We have our optical camera at the top here. The PCBs for different subsystems, the power supply. Then we have just a SketchUp of the structure, the mechanical structure of the project, of the satellite. At the bottom here, okay, it's not complete, but we have a GPS antenna here. It's supposed to be GPS antenna. We have a sun sensor. We have an optical camera at the top also. I don't know, this looks very ugly, but these are some frames. I was just reading on, or rather looking up on how to attach the different frames. I mean, I was way ahead of the design, which is a bad thing, but we'll get to this also. It's a part of the subsystems we are going to build. So the goal of this project is to learn. I want to learn and deconstruct, especially on the software side. The hardware side is pretty basic for this. It's not going to be space grade, obviously, because not restrictions, but what are they called? Shortcomings of, things like budget, availability of some materials, and etc. that I think I foresee. So we are going to make everything using locally available devices. We have some subsystems we are going to build. We have the power supply, obviously. We have to have a way of handling the data and telemetry to the ground. So think of this as a satellite in space. So we need a way of transmitting that data to ground and processing it. Structure and the thermal subsystem, the onboard computer to handle all the housekeeping tasks and processing and manage everything on board. We should have a way of maintaining the attitude of the rocket in orbit, and also a way of determining where it is in orbit. So and some other subsystems that I'm sure they are, but I've not looked into them yet. So all of this is subject to change, but at least we have a starting point. So my other issue was, if we have the time, in the course of the project, we can design these solar panels to be deployable. I know a company that builds that specific part of a satellite. Just they specialize on the deployable satellites. They call them the TP something, TPS. I'm not sure. Yeah. Anyway, so my interest is on the algorithm that does this job, the algorithm and the mechanical mechanism that builds that. So I'm not very mechanical, but I mean, there's no harm in just knowing how to design such a specific part, and it works. So obviously it's a satellite, so they'll be following the sun, using the sun sensor and maximizing their position in orbit so that they have the maximum energy, or they store the maximum power or charge in the batteries. So the next thing is how we are going to build the software stack. So most of these high critical or other critical systems use the real-time operating systems. They use I'll just write down here. They use the RTOS, right? Real-time operating systems. And okay, previously I've used the free RTOS, which is good. I am pretty conversant with this, but I don't want to use this for this satellite. So I'm going to use a rather advanced RTOS, which is called RTEMS, which is real-time executive for multiprocessor systems. So it's also an RTOS that provides the multitasking features and a lot of other very powerful features. I'm sure they have a board support package for Raspberry Pi, a BSP for Pi, because I intend to use a Raspberry Pi for this job. This is what I have at the moment, the Pi. I don't want to use a lot of money to buy other boards. I want to try it first on the Pi, and then if it works or doesn't, if it doesn't work, then we can try other boards. So the reason why I'm using a Raspberry Pi is because I have a lot of, I have one Pi lying around, then I have other modules for the Pi. For example, I have a camera somewhere around here. Pi camera, yeah. So this is the Pi camera we are going to use for the optical imaging. So this is going to be our payload, basically. We are going to use this satellite to take pictures of something. I won't do image processing and all that other stuff. I'm not interested in that part. I'm interested in the hardware and the RTEMS part. So I've never used RTEMS before. I've just looked into the projects that have been built using RTEMS. And just to name a few, there is this project by the European Space Agency. It's called the EarthCare. EarthCare is a way of monitoring the space around the Earth for aerosols and to see how the effect of aerosols is. That's one of them, built using RTEMS. We have I don't remember the name very well, but we have an imaging telescope that uses RTEMS to do some image processing and overlays. We have some Mars rover mockup using RTEMS too. So my point is, basically there are a lot of open source projects that have been built around this system that we can deconstruct. So we will go deep into them and see how they have organized their code, what they have done, how to set up all that stack, and probably learn from them, and then we deploy all of that knowledge on our satellite. So it's going to be a series of videos. We will build a subsystem by subsystem, one at a time. sometimes when you intend to like build two concurrently, so that if they are very highly dependent, we can do that too. But yeah, that's basically about it. I'm going to share the links, the designs, the research papers, research documents, books, videos, anything I find around RTEMS and the nanosats with you, so that if you want to contribute, you want to support, you want to learn with me, or you just want to learn from what I learn, you can feel free to jump in. Yeah, so see you around and let's do this. Bye bye.